upload the one where you were yelling at us from the fire drill?
No, surprisingly enough, I actually had turned it off.
Oh.
And then I yelled at you and then I turned it back on. So it was totally unintentional.
Gold.
Okay. Here we go.
It's not bad. It's just
Alright. So, how are we feeling about compounding interest, simple interest, and compounding continuously? Straightforward, not too bad. Great, we're done. We're moving on.
Yes.
Okay. We're going to go back to recursive and explicit algorithms. I'm going to give you guys basically the four equations. I'm going to give you the four equations which you may or may not have. But we're... No, they're the same.
I can't take this anymore.
So, we had two types of sequences we talked about back in September. Does anyone remember what they're called? Yes? Arithmetic and geometric. Back then, I said this was a preview of what we're going to be getting into. Okay? This is a preview of what we're going to be getting into. So, we talked about four equations that went with these, and they went into two camps. Do you guys remember what those two camps of equations were?
Recursive and decursive. No, recursive and explicit.
Okay. Recursive and explicit.
Why are we doing this again? Just wondering.
Good question. Why are we doing this again? Well, arithmetic, what kind of equation was an arithmetic sequence? What did it kind of look like? Brennicky.
You spelled it wrong. Oh, there you go.
Okay. So,
I can tell you the answer too.
okay, you got it?
What was the question?
So the question was, what kind of equation does an arithmetic sequence look like?
That was what it. If you know the first one, wait no. It's that you can just find the next one in the sequence.
Okay, that's kind of what they are, but I'm talking arithmetic in general, guys. What does an arithmetic sequence look like?
Kind of like a slope.
Okay, something about a slope, Michelle?
Isn't it like a pattern of numbers that they
If that follows the rule, absolutely, but what?
Common difference.
They have a common difference. They have a common difference. Okay. If we were to talk about graphically what this looks like, what does an arithmetic sequence look like? Yeah, right.
A line.
A line. Okay? So this is something that looks like a line. It has a constant difference. It has a constant slope. So for a recursive formula, what that means is we need to know the prior information to get the next one. Or, if we want a sub n, we need a sub n minus 1 plus some common difference.
Oh, yes, I remember this.
Alright? So if I wanted to find the 55th term, what do I need to know?
The 54.
The 54th term. I need to know the term right before it. And that is kind of the lame thing about the recursive version, is that we have to know everything up to it in order to find the next one. No way around that with recursive. However,
But so then why is there even a recursive formula if you can just use this?
Yeah, you can just use your head.
the recursive formula can help us see what's going on. Okay?
Okay.
So by being able to identify a difference,
Because it shows that there's.
yeah. And what we're going to do today is today could be a train wreck, I'll throw that out there now. Is I'm going to throw some patterns at you guys. And I'm going to say, find the formula, find the pattern. Give me an equation. Predict what the 100th term is going to be. How many dots are there going to be after 100 minutes? And you'll see what I'm talking about in a few seconds. Okay? But the idea is that it'll help you kind of formulate what's going on. The explicit formula, however, Brennicky's absolutely right. To be completely blunt, this is a nice midpoint to getting to this. But once you've got an explicit formula, there's very little reason to go back to recursive. In fact, to be completely blunt, I don't know why you would. It doesn't help you. The explicit says, okay, well we know our first term, our initial value.
That's what O means?
Yep. we have our common difference and the number of terms between 0 and the one we're looking for, or the initial value of the one we're looking for. Multiply that by the common difference, add that together, boom, you get that. Okay? So again, it's a line. There is nothing about this that says exponential. Yeah?
So are you adding D or multiplying by?
This one you're adding. This one you're taking the number of terms between your initial one and the one you're curious about, and multiplying it by D. Okay? Any questions on that? Yeah?
Will we have something like this for homework?
Probably not. I don't think you're going to wind up with homework tonight. Okay. Next one, the geometric. If we're talking about the recursive, what's the thing with the geometric? What's the deal with the geometric?
I don't remember what it's called, but isn't it like multiplication and division?
It is multiplication and division. That's a great way to think about it. This is addition and subtraction. You're adding or taking away a term each time. This one we say is a common ratio.
Ow.
A common ratio. And at first, for the recursive, we're not going to see why we're talking about it in this unit, but you'll see why when we look at the explicit. Because what is this unit all about? Exponential functions, exponents. So for our recursive, if we want to know what a sub n is, again, we need to know the one before it, a sub n minus 1, and we're going to times it by some common ratio, r. If we see a pattern where we're multiplying by 3 every time, well, I just multiply by 3, I get the next term. I multiply by 3 again, I get the term following that.
So then why would you subtract 1?
Here,
Wouldn't you subtract 1?
this says, in order to find the 55th term, I need to know the 54th term.
Oh,
In order to find the second term, I need to know the first term. That's all that says. Last, a sub n equals a sub n, or sorry, a sub naught, or the initial value, r to the n minus 1.
Wait, that. So it's
Because that A to like O?
not.
No. A sub 0. Sometimes you'll hear it said a sub naught or a naught. It just
That's
means
just the first one.
it's the first one. It's your initial term. If you know your initial term, you can find that one. Martha.
Maybe times R or multiply by?
Yep. If I don't put anything in there, it's assumed times.
And then n minus 1.
N minus 1.
To the power of n minus 1.
Yep.
Seems legit.
Seems legit. That's good. Yes.
So
I'm sorry?
what does R represent?
R represents the ratio.
We said
So, we'll talk about that in a second then. Okay? So let me take a step back. I'm going to give you guys 2 really quick sequences just to demonstrate what I mean by difference and by ratio. Alright? I don't want you guys to write anything down because you've already seen this. So let me kind of whiz through this as fast as I can. And we'll make sure that we understand what's going on, what a difference is and what a ratio is. It should refresh your memory on what you've done, and hopefully that can be the end of it. Sound good? So, let's say we have A, or let's just call it X and Y.
Yes.
Yeah. A and
X.
N and A.
That's a theory.
Okay, so for our first term,
Don't write this down, Jenny.
don't write this down.
Jenny, don't
1,
write it.
3, 5, 7, 9, 11.
Did you make those up?
Yes. Okay, so for our first sequence of numbers, what is the pattern you guys see here? Roll.
It increases by 2 every thing.
Okay,
Every time.
we're adding 2 each time. Adding 2. A common difference is adding or subtracting. Okay? Next one.
I don't.
Okay. This time, what do I have to do to get to 2?
Multiply by 2.
I times by 2.
No, you don't. Because 2 times 1 is 1.
Times 2?
Yeah.
Times 2? times 2, and times 2. That's the difference. The common ratio is that we're multiplying or dividing.
So for R, would you put 2?
Yep. Perfect. Does anyone not understand that? Because that's really kind of key to understanding what's going on. Haley?
Wait, so for common difference, you add it?
Add or subtract.
Okay.
Here's, and I've said this before, I'll say it again, and I'll say it more throughout the semester. Here's the dirty little secret about math. There's 2 operations. Addition and multiplication. Okay? Subtraction is the same thing. These 2 are both adding or subtracting. There is no difference in math between these 2. Nothing. Similarly, multiplication and division are the same thing. It's the same thing. There is no difference. Yes?
So if there's no difference, then why would you make them like why wouldn't you just have addition and multiplication?
Because you guys have a really hard time appreciating this. So we say, okay, we're going to call them different. Because if I write -2 on the board, you guys see that? You go, oh my god, it's negative. So we say, okay, well, let's just treat it differently. But as you get further in math, when we start defining what makes what's called a ring or a field of numbers, there are rules that define how numbers play with each other in math. You guys have seen one set of rules. I can give you another set of rules that says you can add these things together, but they can never be a even number. Doesn't exist. Or I can give you another set of rules that says you're going to have a base 8 system. Or modular mathematics. There's all these different rules out there that all come down to how do you define addition, how do you define multiplication. And when you talk about that, then you start to see that there is no difference between these 2. They work the same way.
Okay.
Okay? Okay there?
Yeah.
Okay.
There's a lot to take in.
So, they're the same thing.
Okay.
Alright, so common difference, addition, subtraction, common ratio, multiplication, division. Any questions? All of you, here we go. Now, when you guys were working last week and I was not here, I gave the sub a packet for you to work on. Those of you who were successful at the packet were able to identify what was going on. You had to make a table.
Oh, that's really calculated.
You had to make a table. I'm going to say this today. The tables that are up there may be helpful. And you may want to add a 3rd column to them.
To those tables right there.
No, the ones on the
So we have 0, 1, 2, 3. We have our numbers 1, 3, 5, 7. Looking at these formulas, specifically looking at this one, how can we write what's going on here in this column? Well, 1. I should have started 1. Okay. They're starting at 1. Okay, so 1 plus. Man, I'm failing. Here, let me just get my notes.
Or you could just give us a packet.
I'll just give you the packet. How about that? We'll see how it goes. I need to find my notes so I can give you those. Okay.
Aiden, not in school. Take it home.
Go.
This is an interesting.
I don't know why you're so weird right now.
I don't know why.
It's just me.
Okay.
Go drunk to your home. More sense.